Okay, the second half of our review for Unit 13 is simplifying rational expressions, right? So we're going to be multiplying, simplifying, adding, subtracting, and having our complex fractions. So in number 8, there's only one rational expression, and all we're going to need to do here is factor and cancel to simplify the expression. So what I would do is start by factoring the numerator. So when I multiply 3 and 15, I get 45, not 35. And I need to find two numbers that multiply to 45 and add to negative 14. That would be, let's see, negative 5 and negative 9. Right, so let's split the middle here. Let's get our factored form so that we can then put it right back into our rational expression. So we'll have 3x squared minus 5x minus 9x plus 15. When I group, I pull out my GCS, which here would just be an x, times 3x minus 5, minus 3. There we go. So our factored form will be x minus 3, 3x minus 5. That will be the new numerator of our expression. All right, now, we've done these factored forms here before where you have 9 minus x squared. I'm going to show you one thing here. When I factor 9 minus x squared, I get 3 minus x and 3 plus x. That's the difference of squares. I have to write it in that order. However, what's going to happen here if I write 3 minus x, 3 plus x, is that x minus 3 and 3 minus x, they're really close, but they're not quite the same thing. So what you do in this situation, if you remember, is you're going to factor out a negative 1, which would really make this negative 9 plus x squared, but that's negative 1. If I rewrite it, x squared minus 9, which then allows us to factor that with difference of squares as x plus 3, x minus 3. Now you can see that the factors look exactly the same, and the x minus 3's are going to cancel. So if you have difference of squares where the number is first, typically it might help you to factor out a negative 1 so that you can rewrite the expression with the variable first if that helps you to cancel things. Your final answer here takes your numerator, 3x minus 5, and our denominator, negative x plus 3. You can put the negative in front of the entire fraction if you want, in front of the numerator. It doesn't matter as long as the negative is there. Okay, so that would be your most simplified form. Looking at number 9, we're adding two rational expressions here. There's a plus sign in the middle. In order to add rational expressions, you have to have a common denominator. So the common denominator here is going to be 2x and x plus 2. Okay, so our goal, once we add things together, we'll have this as our denominator, 2x times x plus 2. Well, the left fraction is missing the x plus 2. So what you have to do is you have to multiply the left fraction by the x plus 2, the part of the denominator it's missing, and the other fraction here on the right is missing the 2x. That'll get both denominators to be what we want. Now we just have to simplify the numerators. You guys know that I'm going to write this all out in the all the steps out here, but if you want to shortcut it, you can. All right, we have x plus 2 times 1, so that's really 1 times x plus 2. That's our numerator on the left. And the numerator on the right here is plus 1 times 2x. Now, I know you don't always have to write out the 1 times, but I wanted to make sure that we saw what was happening with multiplying the numerators. What that gives us is the same denominator, 2x times x plus 2. The left part of our numerator stays the same, x plus 2, and then plus 2x. So now all you have to do is combine like terms, cancel, factor. Factor and cancel if necessary. So my numerator here, 1x plus 2x is 3x plus 2 over 2x times x plus 2. That's actually your final answer. The numerator doesn't factor any longer, and nothing is going to cancel off. I can't cancel the x's in front here, so don't do this. That is not allowed. You cannot cancel those x's. You cannot cancel the 2's. That's a bad thing as well. That is your final answer. Number 10. Oh, a complex fraction. What we've been working on is our last lesson here. Remember that our suggestion to solve these simplify these complex fractions will be to find a least common denominator or a common denominator, as my class likes to hear it. I look between 36, x squared, and 6x, and it seems that the common denominator between all of those fractions is going to be 36, because 36 encompasses the 6. It needs to be able to cancel the 36 off, so I need to have a 36 there so that the 36 will go away. X squared. Again, if I just did 6x, now don't write this down, but if I just chose 6x, that would not cancel fully the denominator for that left fraction, or the right fraction. So we need to make sure that we choose a common denominator that will eliminate every one. So now I multiply every single fraction by 36x squared. And now I'm going to cancel the denominators. If it helps you, remember you can write these over 1. If it helps you remember that we're multiplying numerators and denominators here. Alright, so the 36's will go away. So what I'll have in that top left fraction, all I'm going to have left is x squared times 1, which is x squared. The next fraction, the x squares go away, so you'll be left with minus 1 times 36, which is minus 36. Bottom left, so the 36 cancels, so I have x squared times 1, which is x squared. And over here, the x on the denominator goes away, and it cancels with one of the x's up here, so I'll just have an x. The 6 cancels with the 36, so I'll have a minus 1 times 6x, minus 6x. Factor now. So x squared minus 36 will be x minus 6, x plus 6. My denominator just has a GCF of x. So to pull that out, I will have x minus 6 left. When I cancel the x minus 6's here, my final answer is x plus 6 over x. Again, those x's cannot cancel because the plus sign right here blocks you from doing so. That is the most simplified form. Number 11, we are multiplying. When we are multiplying rational expressions together, you are free to go ahead and start by factoring everything. So top left of this expression, I'm going to pull out a GCF of x. I'm going to be left with 3x minus 2. The denominator there, I'm going to factor out another GCF. It looks like 5x is the denominator there. So I'll have an x minus 1. Alright, let's deal with the second fraction now. My numerator can factor as difference of squares. X plus 1, x minus 1. And the denominator here I'm going to need to do split the middle. Alright, so off to the side I need two numbers that multiply to negative 6 and add to 1. That would be 3 and negative 2. So if I factor that, 3x squared plus 3x. The GCF for the first term is 3x. It's x plus 1 minus 2. X plus 1. So it looks like the denominator there will be 3x minus 2. X plus 1. That's really good because let's see what cancels. The 3x minus 2 cancels with the 3x minus 2. The x minus 1 over here cancels with this x minus 1. Oh, I'm missing the easy one. The x's will go away. Go away, x and x. The x plus 1's go away. So what I'm left with is, be careful here, a 5 in the denominator. Now notice that every term in the numerator here is canceled off. I have to put a 1 to replace it. That 5 is still in the denominator. It doesn't just miraculously come to the numerator. The answer here is 1/5. Number 12. All right. We are dividing rational expressions here. So what you're going to do is you're going to flip the second and multiply. So remember, the saying is, when dividing fractions, don't ask why, flip the second and multiply. The first thing I'm going to do before we flip the fraction is, we did a problem like this earlier, back in number 8. When I have 25 minus x squared, it is probably going to be beneficial for you to rewrite that as negative. Remember, we're going to pull out a negative 1 there, because that's really going to be negative 25 plus x squared, which I can rewrite as x squared minus 25. If you do that right from the beginning, factor the negative 1 out, it'll help you see all the canceling a little bit later. So that's all I'm going to do first. I'm not going to factor anything else. I'm just going to rewrite this as multiplication so that you can see it. You can always factor earlier than I do. Okay, now that I've made the second fraction its reciprocal, flipped it, and multiplied, now I'm going to factor everything. This is now where I'm starting. So the top left here, you're going to have the negative 1 in front, and I have a difference of squares. So x minus 5, x plus 5. The denominator here has a GCF of 3, so I'm going to pull out 3 and have 2x minus 1. Now my second fraction. Numerator is also difference of squares. 2x minus 1 times 2x plus 1. And then I have to think about split the middle here. I need two numbers that multiply to negative 10 and add to negative 9. So I'm thinking negative 10 and 1. When I split the middle, I'll have 2x squared minus 10x plus 1 minus 5. And what will we have? 2x times x minus 5 plus 1 times x minus 5. Looks like that'll be good for us because when I rewrite my factored form, we'll have 2x plus 1 times x minus 5. And you should see a lot of things that are going to cancel here. 2x plus 1 and 2x plus 1. 2x minus 1. The x minus 5s are going to cancel. And that's it. So my numerator is negative x plus 5 over 3. And that would be your final answer. Or you could rewrite that if you really wanted to as negative 1/3 times x plus 5. Either way, those are equivalent answers. All right, let's look at number 13. We are subtracting two rational expressions here. In order to subtract, you have to have a common denominator. So what my suggestion is to find the common denominator is to first factor both expressions so you can more easily find the denominator. On the left, I need two numbers that multiply to negative 3 and add to 2. So I'm thinking x plus 3, x minus 1. That would be the new denominator. And over here, I'll pull out a GCF and have x plus 3. Now, when I look at my denominator, I have x plus 3 and x minus 1. The right side also has an x plus 3, but in addition it has an x, which means that since they both have an x plus 3 has to be in my denominator. The right side has an x, which means the left side is also going to need an x. And then the left fraction has an x minus 1, which means that's what the right fraction needs. So all three of those factors, x times x plus 3 times x minus 1, is going to be your common denominator. Now we need to multiply our fractions by what's missing so we can simplify. The left fraction, all that it's missing from that common denominator is an x. So we multiply by our fancy 1, x over x. The right side, what I'm missing is going to be x minus 1. Now I'm going to multiply the numerators because I know my denominator will end up being x times x plus 3 times x minus 1. So my left fraction is going to be x times 8, which is 8x. Here's where I want you to be careful. This is really a negative here. That minus is like a minus 6 being distributed to the x minus 1. So the way I like to write it is to take your time and not skip steps and just write negative 6 times x minus 1. That way you make sure you're distributing correctly. You're not just distributing the negative to the x, but also to the negative 1. Now I'm going to simplify my numerator. I cannot cancel things. Don't be that person that crosses things off right here. You're not allowed to do that. You can only cancel things once you have collected like terms and you're in fully factored form. Right now our numerator is not in factored form. When I distribute there, I'll have minus 6x plus 6. So when I combine like terms, 8x minus 6x is 2x plus 6. And then my denominator stays the same for now. I can simplify the numerator. I can factor it. Factor out a GCF of 2 to be x plus 3. And you should be able to see at least the x plus 3's are going to cancel. Go away. So my numerator is of 2. The denominator is x times x minus 1. That is the fully simplified answer. All right, we just have a couple more. Let's look at 14. Again, we are subtracting here. All right, so the nice thing about this problem is, look, when I'm subtracting, I actually already have a common denominator. 16 minus x squared, 16 minus x squared. So what that gives me, or allows me to do, is from the beginning to subtract the numerator. I have x squared. Now I want you to be careful. Minus 2x plus 8. Right? We're not just minus 2x with a positive 8. I'm subtracting the whole quantity 2x plus 8. Okay? I hope that makes sense. When you subtract here, you're subtracting all of that, not just the 2x. You're subtracting 2x plus 8. Now, let's simplify. There's a couple things I want to do first. I need to distribute this negative 1 that's here. And then in the denominator, when I have the 16 in front for the difference of squares, remember, I'm going to pull out a negative 1 here. And I'm going to rewrite this. So let's rewrite the whole expression with everything simplified there. I'll have x squared minus 2x minus 8 all over negative x squared minus 16. Remember, that trick is going to help us factoring out the negative. All right, factoring the numerator. The numerator will factor to the x minus 4, x plus 2. Pull out a negative here. And difference of squares, x minus 4, x plus 4. The x minus 4's cancel. So you are left with x plus 2 over negative x plus 4. The negative doesn't have to be in front of the denominator, it can be in front of the whole fraction. But that would be your fully simplified answer. All right, so remember, when you are subtracting, this is where people make mistakes. When you're subtracting rationals, make sure you put the quantity you're subtracting in parentheses so that you're careful about your signs. Number 15, division. So what we do, remember with division, is that we multiply by the reciprocal of the second fraction. So we really have 5x squared plus 30x over 10x squared times this reciprocal. You flip the second fraction. Now that I'm in multiplication, I can worry about factoring and canceling. So the numerator on the left, I can factor out a 5x, and I'll be left with x plus 6. The denominator doesn't cancel, 10x squared. My numerator on the left, I need two numbers that multiply to negative 12 and add to negative 4. Be negative 6 and positive 2. And the denominator is difference of squares. So if you forget difference of squares, you will not forget it this unit. We've seen that a lot. All we have to do now is cross things off. So x plus 6's, those will go away. The x here will cancel with one of the x's down here. So I still have an x in the denominator. The 5 cancels with the 10, but I still have a 2. So my denominator there is 2x. And these x minus 6's will cancel. So all that's left in my numerator is x plus 2 over your denominator of 2x. That would be it. All right, 2 more problems. Number 16, I am adding rational expressions. So in order to do that, I need a common denominator. To find the common denominator, I have to factor first. So let's see what we would have. 2 numbers that multiply to negative 4 and add to 3. Positive 4 and negative 1. And then the factor on the right here, when I factor on the right, I get x times x plus 4. Similar, this is a very similar problem to number 13. When I find my common denominator, they both have an x plus 4, so that's going to be in my denominator. The left fraction has an x minus 1, so I need to include the x minus 1, and the right fraction has an x. So I'm going to need to include all of those parts, all of those factors in the common denominator. The left fraction is only missing the x, so I'm going to multiply by x over x. The right fraction is missing the x minus 1. So when I rewrite this here, and I'm going to write out the long way like I usually do. The left side I have x times x minus 6. Then here I have a positive 8 this time, which makes it a little easier. Positive 8 times x minus 1. Again, don't cancel anything yet. You have to distribute and simplify and then factor again. So when I distribute here, and distribute the x, that gives me x squared minus 6x plus 8x minus 8. When I collect like terms, that'll give me x squared plus 2x minus 8. All right, and then over my common denominator, now I need to simplify by factoring the numerator. So two numbers that multiply to negative 8 and add to 2 would be 4 and negative 2 over my common denominator. And you are now able to cancel off the common factors, which are x plus 4. That's it for here to simplify. So I have x minus 2 over x times x minus 1. All right, last problem, a complex fraction. 2 plus 10 over x, and x over 5 minus 5 over x. The common denominator here that I'm going to use is going to have an x in it because of my two fractions, and then also 5, so 5x. I'm going to multiply every fraction by 5x. That will clear the denominators and really simplify things for me. Top left here, 5x times 2 is 10x. On the right, the x's are going to cancel off, so I really just have 10 times 5, which is plus 50. On the bottom left, the 5's cancel, so I have x times x, which is x squared, and here the x's cancel, minus 25. I'm going to factor. The numerator has a 10 as a GCF, which can factor out x plus 5. My denominator is difference of squares, x plus 5, x minus 5. Notice the x plus 5 will go away, so all you're left with is 10 over x minus 5. That's your most simplified answer. All right, if you have other questions, you should ask your teacher for some help. Make sure you understand that half sheet that we did on Monday, which is on the algebraic atrocities, and you should be all set. If you need more practice, your teachers can find you or give you some.